Morning, class.
Good morning, Lois.
Morning, 老师。
Okay. Today, we are going to study Unit 3, Screw Joints and Screw Drive. There are 9 goals for this unit. A screw thread. Master the basic concept of screw thread and know the types of screw thread. And know the pre-tightening or preload and loosens preventing of screw joint and strength analysis of screw joint. And the objective 1 to 5 is what we will study today. And today's lesson is very difficult, so you should pay much attention. And now let's get started. The forming of screw thread. To understand the formation of threads, we must first take a brief look at the helical line. The helical line is the locus of a moving point which rotates along the axis and at the same time moves along the axis in constant velocity on the surface of the cylinder, and then the helical line forms. If a plain finger like this moves along a helical line and keeps itself through the axis of the cylinder when moving, then screw thread is formed like this. This is the screw thread. And different types of screw threads are classified according to various criteria, such as function, profile, pitch, position, and so on. For example, according to the type of tooth of screw threads can be divided into square screw thread, triangle screw thread, trapezium screw thread, and buttress screw thread. These are schematic figures of square, triangle, trapezium, and buttress thread. Among them, the square thread has the greatest strength and efficiency. According to the direction of helical line, the screw thread can be divided into right-handed thread and left-handed thread. This is the right-handed thread, and this is the left-handed thread. Threads are universally made in right-handed. That is, if the bolt is turned clockwise, the bolt advances towards the left. According to the number of helical line, the screw thread can be divided into single stud thread and multi-stud thread. The multi-stud thread have two or more threads cut beside each other. This is the single stud thread, and this is the multi-stud thread. And according to the thread position, external threads are the threads on the screw, while internal threads are the threads on a nut or thread hole. And external thread and internal thread form a screw pair. This is the internal thread. It's the thread on external thread is thread on a screw like this. And this is the internal thread. Is the thread on a nut or threaded hole like this. This is the external thread, and this is the internal thread. And according to the thread function, screw thread can be divided into joint screw thread and driving screw thread. This is a joint screw thread. The joint screw thread plays the rule of connection, and this is a driving screw thread. The driving screw thread can transmit force and movement. The triangle thread is joint screw thread. And square thread has the greatest strength and efficiency. It is driving screw thread, but it is more difficult to fabricate. By comparison, repeating thread and buttress thread are easier to manufacture. Trapezing thread is selected to carry bidirectional loads, and buttress thread is for unidirectional loading. And for the two types of screw thread, the triangle thread is joint screw thread. The square thread, trapezing thread, and buttress thread is driving screw thread. According to the shape of body of revolution, screw thread can be classified into parallel screw thread and taper screw thread. The left thread is parallel screw thread, and the right thread is taper screw thread. Screw threads also can be divided into fine threads and coarse threads. Okay, so There are types of screw thread. We have learned about the classification of threads. Next, we will learn the primary geometry parameters of screw thread. First, the major diameter D. The major diameter D, as shown in this finger, is the largest diameter of screw thread, the major diameter D. Then the minor diameter D1, the minor diameter D1 is the smallest diameter of a screw thread. And pitch diameter or mean diameter D2. There is D2. D2 is the diameter where the length of thread and the groove are equal. The length of thread and the groove are equal. Is for D2, the pitch diameter or mean diameter. Thread pitch P. From there to there. The actual distance between corresponding points on adjacent threads. The pitch, this is the pitch of the thread. Lead S or L. Lead, there is the lead S or L. Is the actual distance the mating thread or knot will advance in one revolution. For a single threaded screw, S, the little S or L is equal to P. But for multi-type screw thread, the little S is N times P. N is the number of threads. And lead angle gamma or pussy. Lead angle is the angle between the perpendicular of the screw axis and the rise of the thread. For lead angle, we have this relationship. Tangent push or tangent R is equal to the lead S N times P divided by time times D2. D2 is the pitch diameter. And included angle alpha or thread angle alpha. Thread angle alpha is the angle between the flanks of adjacent threads measured in an actual plane. This is the thread angle alpha. And blank angle batch is half of the thread angle alpha. And contact H H is the radial distance between the major distance and minor the major diameter and the minor diameter. This is contact H. So these are 8 parameters for screw thread. The major diameter D, the largest diameter of screw thread. The minor diameter D1, the smallest diameter of screw thread. And pitch diameter D2. D2 is the diameter where the wings of thread and groove are equal. This is for D2. And thread pitch. And lead SOL. For single thread screw, L is P or S is P, but for multi-type threaded screw, the leader is N times P. P is the thread pitch. Okay, and lead angle and threaded angle there, and contact height. The radial distance between minor diameter and major diameter. Okay, this is for the lead angle. We have the tangent push or tangent gamma is equal to S over divided by pi times D2. Okay. There are 3 processing grades for screw thread: A grade, B grade, and C grade. A grade screw thread has small tolerance, high processing, universally used in occasion that the fit is precise. B grade screw thread can be used in such occasion, bearing heavy load and being disassembled or adjusted frequently or bearing variable load. C grade screw thread is used in general joint in most common use. And the major diameter of regular screw thread is the nominal diameter. There are variety of thread pitches of the same nominal diameter. For example, for this screw thread, the major diameter or the nominal diameter is the same, but their pitches are different. Thereinto, the screw thread having the maximum thread pitch P is called coarse thread, and the rest are called fine thread. So, the left thread has the maximum thread pitch. It is coarse thread. Coarse threads are recommended for ordinary applications, especially where rapid assembly or disassembly is required. And for fine thread, the lead angle is small. For fine thread, the lead angle is small. Let me see. For lead angle pussy or gum, we have this tangent gum is equal to the lead divided by pi times d2. For fine threads, the lead S is small because S is M times P. For fine threaded, P is small. Okay, like this. For the fine thread, P is small. P is small, so the lead angle for fine thread is smaller than coarse thread. And fine threads have better capability or resisting loosening for vibrations because of their smaller lead angle. They have a smaller thread depth. The smaller depth is the thread depth is small, and large root diameter or large mylar diameter that provide higher static tensile stress. And fine threads are used in automobiles, aircraft, and other applications that are subjected to vibration. The performance comparison of four threads is listed in the paper. The self-locking, efficiency, and root strength. Level 1 represents the best performance. 4 represents the worst performance. So, for triangle thread, it has good self-locking and root strength. And for square thread, it has good efficiency. And the triangle thread is joint screw thread, and square trapezium and battery thread are driving screw thread. And This is the diameter and pitch basic dimensions of coarse thread. For example, M24 1.5 is a thread with a nominal major diameter of 24 millimeter and a pitch of 1.5 millimeter. The metric threads are dilated by M followed by major diameter and a pitch in millimeters. This is the basic dimensions of trapezium screw thread. Okay, and these types of screw thread. The triangle thread is joint screw thread, and square screw thread, trapezium screw thread, and battery screw thread are driving screw thread. Okay, this is the basic conception and types of screw thread. Then there is the types of screw joint. Threaded fastening are the basic assembly method in the design and construction of machines. Threaded fasteners join the machine external and internal threads together by the following typical method. First, the bolted joint. The bolted joint, it is designed to let a bolt to pass through holes in mating members and secured by tightening a nut from the opposite end of the bolt. This is bolted joint. It includes ordinary bolted joint and precision bolted joint. For the ordinary bolted joint, it have a clearance between the hole and the body of screw. There is a clearance. And for precision bolted joint or rammed hole bolt, it have rimmed holes without appreciable clearance. Both of them are applied to join relatively thin members by using thistle holes. And this is the remaining length of thread for remaining hole bolt. And if the bolt is subject to static load, the length should latch 0.3 to 0.5 times D. And for variable loads, the remaining length should latch then 0.75 times D. Okay, and for shock loads or bending loads have the length less than D. And this is the extension elongation of thread A. A is 0.2 to 0.3 times D. And the second type of joint is screw joint. It applies when one of the jointed members is too thick to drill hole, or the space is too small to mount a latch. And the stud joint is a stationary bolt attached permanently to one of the members to be joined. A stud joint applies when one of the jointed members is too thin to drill a body size hole to, but the screw for the screw joint, it cannot be disassembled frequently, but the stud joint can be disassembled frequently by removing the latch and washer without damaging the threaded member. And these are applied when one of the joint components is too thin to drill a body-size hole. The screw joint cannot be disassembled frequently, and the stud joint can be disassembled frequently. And these are parameters. And this is the screwing depth in the base edge. The holding screw joint or set screw joint is designed to be inserted into a tapped hole to bear directly on mating element. And a set screw depend on compression to develop clamping force to lock components into place. This should not be used in vibration applications where loosening would impose a safety hazard. So, there are two types of screw joint. For the bolted joint, it's can be applied to joint relative thin members by using several holes, and screw joint and stud joint are applied when one of jointed component is too thick to drill hole, but screw joint cannot be disassembled frequently. The stud joint can be can be disassembled frequently. Okay, then there is the threaded fasteners. The threaded fasteners are standard. It includes bolt, a stud, screw, nut, washer, and so on. This is a bolt. Bolt is a handed and threaded fastener designed to connect two unthreaded components with the edge of a nut. The bolt is used in the bolted joint. Bolts have standard thread length L0 and total length L. The length L0 and L is standard. Various standard head styles and thread configurations are readily available. This is the structure of bolt. Stud. A stud is a headless fastener threaded on both ends and is uniformly screwed permanently into a tapered hole. And this is the finger of stud. The stud is used for stud joint. Screw. A screw is a headed, threaded fastener designed for the assembly of two components, one of which contains its own internal thread. Screws generally have several head and end structure and are tightened by a screwdriver into tipped holes. These are screws. Screw is used for screw joint. For screw joint. Okay. And holding screw or set screw is headless and is designed to bear directly on the mating part by being inserted into tapered holes. So this is a set screw. It is headless. It is headless. and the holding screw or set screw is used for set screw joint. Okay, and the latch. The purpose of using latch is to make the threads deflect to distribute the load of bolt more evenly to the latch. These fingers show common latch, the hexagon latch, flat hexagon latch, thick hexagon latch, and round latch. The washers are used under a bolt head or under both a bolt head and the latch. The basic type of washer is a plain flat washer, and the function of washer is to increase the bearing area in order to decrease pressure to avoid sketching the surface while tightening up and to prevent looseness. This is A-type plain washer and this is B-type plain washer. Now, let's review what we just learned. The primary geometry parameters of screw thread, and you can find this on page 62 in your book. The major diameter D, the largest diameter of the thread, and the minor diameter D1 is the smallest diameter, and pitch diameter D2. Pitch diameter D2 is the diameter where the lengths of thread and groove are equal, and thread pitch P is the actual distance between corresponding points on adjacent threads. Lead S or L. Lead S is the actual distance the mating thread will advance in one revolution. And for single threaded screw, L lead is equal to the thread pitch P, but for multi-type threaded screw, the needle is N times P. N is the number of threads, and lead angle, push or gamma, is the angle between the perpendicular of screw axis and the rise of the thread. We have relationship. The tangent push or tangent gamma is the lead divided by pi times D2, and included angle or threaded angle alpha is there, and the flank angle bet is half of the alpha. The contact height H is the radial distance between major diameter and minor diameter. So these are parameters. And we know the types of tools of screw thread. According to the type of tools of screw thread, it can be divided into square thread, triangle thread, trapezium thread, and buttress thread. For square thread, the threaded angle alpha is 0, and for triangle thread, alpha is 60 degree, and for trapezium thread, alpha is 30 degree, and for buttress thread, alpha is 33 degree. And the flank angle beta is half of the alpha. So for triangle thread, the beta is 30 degree. For square, it's 0. And for trapezium, it's 15 degree. And for buttress, it's 3 degree. And these are the performance comparison of the 4 threads. And triangle thread has good self-locking and root strength. It is joint screw thread because of the efficiency is worst. Square thread has good efficiency. It is driving screw thread. Trapezium thread is selected to carry bidirectional loads, and buttress thread is for unidirectional loads. And according to the direction of helical line, the screw thread can be divided into right-handed and left-handed thread. Threads are usually made right-handed. And according to the number of helical line, it can be divided into single thread and multi-type thread. For single thread, need L is equal to pitch P. For double thread, need L is equal to 2 times pitch P. For triple thread, the need L is equal to 3 times pitch P. And for multi-type thread, the need L is equal to M times P. And this is the single start thread. This is the triple thread. And according to the thread position, it can be divided into internal thread and external thread. Internal thread is the thread on a large or threaded hole. External thread is the thread on a screw. And it also can be divided into fine thread and coarse thread. Okay, for fine thread, it has smaller lead angle. Has smaller lead angle. Okay, let's have a break. Have a break for 20 minutes, okay?
Yes, lovely.
Okay. Now let's continue. And this is basic types of screw thread joint for the bolt joint. Usually used for the conditioning. For the conditioning. The clamped members are seen to drill several holes and for the there are two types of bolted joint, the ordinary and the rimmed. So this is the bolted joint. This is the ordinary bolted joint. There is a clearance between the hole and the bolt. And this is the rimmed bolt. And both screw joint and stud joint they are applies when one of the jointed members is too thick to drill hole, and the screw joints cannot be disassembled frequently, and the stud joint can be disassembled frequently. And this is the screw joint, and this is the stud joint. And for set screw joint, it uses a set screw. Set screw is handless, okay? And for the fasteners, the bolt is a bar with a thread for a large at one end and a head at the other. Bolts are used for bolted joint, as shown in figure 3.3a on page 64 in your book. Stud is a bar threaded at both ends. The mating end of the stud is screwed into a tapered hole in one of the parts to be connected, while the large is screwed onto the other end, as shown in figure 3.3c on page 64 in your book. And screw, this is the screw. A screw is a headed threaded fastener. It differs from a bolt in that its threaded portion is screwed into one of the fastener parts without a nut, as shown in figure 3.3d on page 64. And the holding screw is handless, as shown in figure 3.3e on page 64. Nut has a threaded hole to engage the threaded end of a bolt or a stud. Washer is placed under a latch or the handle of a bolt to transmit or distribute evenly the force exerted on the connected parts or to lock them. There are also special screw threaded joints like foundation bolt. Okay, the purpose of a bolt fastening is to clamp two or more elements together. A bolted joint is tightened during assembly before it starts to carry operation loads. And the preload is the force that clamps two or more members together after tightening or preloading. The bolt is preloaded in tension, while the clamped element in compression. And the bolt extension is lambda 1, and the clamped members will be compressed by lambda 2. Two small forces may cause leakage, and two high forces may twist off bolts or screws. So, the value of preload must be properly controlled. For carbon steel bolt, the preload should less than 0.6 to 0.7 times sigma s times A. A is the error. And for alloy steel bolt, the preload should less than 0.5 to 0.6 times sigma s times A. As error, this is use this to calculate the error. D1. D1 is the minor diameter of the thread. Okay. Usually, the preload is not more than 80% of material's limit of yielding sigma s. And the required preload can be controlled by tightening torque T. T can be estimated by that T is equal to T1 plus T2. T1 and T2 are frictional torque in the thread and at the bearing surface, respectively. And after simplified, the formula we have, the torque T is approximately equal to 0.2 times F times D. F is the preload, and D is the major diameter of the thread. We can use this to estimate the torque T. This is a simplified formula. P is approximately equal to 0.2 times preload times the major diameter. Okay, and the preload can be controlled by measuring torque speller and fix the torque speller. Okay, let me see. And this is the measuring torque speller. We can see the output torque value from the instrument. And this is the fixed torque speller. The output torque value is fixed. Okay. And a more accurate approach to determine the value of preload is by bolt elongation measurement, especially for high reliability design. And this is the elongation measurement. So this is before preload, and this is after preload. And the preload may be lost gradually due to wear, creep, impact, vibration occurring during operation. And when the initial preload is lost, the threaded fasteners will loosen. And several methods are available to prevent loosening. For example, increasing supplementary friction, such as using chain nuts or double nuts. Or use split helical lock washer. Also can use special devices by inserting a split quarter pin through the cross hole drilled in bolt, passing through the slotted nut. Like this. We also have the permanently damaged screw thread by braiding and soldering. Okay, let's see the exercise. Two components are to be connected by bolts. One of components is relatively thick, and the connection is disassembled frequently. Which of the following is the best choice? A. Bolt joint. B. Stud joint. C. Screw joint. D. Set screw joint. So, choose which one?
A.
D.
No, A.
A.
Yeah.
Bolt joint. So, one of component is zinc.
Actually, B. Start joint.
B. Okay. The answer is B. Yes. For A, the bolt joint is applied to joint relatively thin members by using several holes. So the collected members are thin. And for stud joint and screw joint can apply when one of joint members is too thin to drill a body size hole, but the for the stud joint, it can be disassembled frequently, but for screw joint, it cannot be disassembled frequently. So we choose B. Okay, two joint relatively thin members and can be disassembled frequently. It's B. And which have better capability of resisting losing from vibrations because of their smaller lead angle. A. Fine threads. B. coarse threads. So which thread had smaller lead angle? Which thread? A or B?
Actually, A.
Yes, fine threads. For the same diameter, a fine thread has smaller pitch P. Okay, so the lead S or L is smaller. So the lead angle is smaller. So the answer is A. A. And double latch is usually used for A. Increasing stress, B. Increasing stiffness, C. Prevent losing. So choose which for the double latch.
Increasing
A.
strength.
Increasing stress, double latch,
Increasing stiffness. Oh,
stiffness.
oh
No,
no.
it prevent
Preventing losing.
Prevent losing. Okay, next.
Okay.
Let's
Actually, let's
see.
see it again, please.
Yeah, yeah. We use double latch to prevent losing. Okay, double latch to prevent the rotation of latch. Okay, so the answer is C. So the available method to restrain a latch from become loose on a bolt is A. Increasing the actual force on the threaded connection. B. Increasing stiffness. C. Preventing relative rotation of screw pair. We choose which?
B.
B. Increase stiffness.
老师
Yeah.
preventing relative rotation of screw pairs.
Yes, because the losing is caused by the
Rotation of
relative
screw pairs.
rotation of screw pairs. So we choose C. C is the answer. Okay. Now, let's study the strength analysis of screw joint. The failure mode of screw joints is related to their stress state. For bolt bearing tensile stress, plastic deformation and vertical fracture are the main failure modes. Okay, this is the picture of fracture. And for the bolts bearing shear stress, shearing and crash are the main failure mode. And for the bolts being disassembled frequently, well, is the main failure form. Okay, let's do the strength analysis of loose bolt joint. For loose bolt joint without preload, the strength criteria is the acting stress. The actual stress should less than the allowable stress. So the actual stress acting on the bolt is the force Fa divided by the area of the bolt. Okay? This is the Fa is the force acting on the bolt. And pi times d1 square or divided by 4 is the area of the bolt. Okay? d1 is the Miller diameter. This is the error. Okay? Any problem?
No.
F, the force divided by error, can calculate the stress. Okay? So this is the actual stress acting on the bolt. So we have this strength criteria. The actual stress should less than the allowable stress. So when we design bolt, we have this. The Miller diameter should large than the square root 4 times Fa divided by pi times the allowable stress. Okay?
Okay,
We have
Lodge.
this when design. So if the external force F increase, the designed D diameter should increase. Okay? And this is for the condition. The bolt is loosen bolt without preload. And for preload bolt joint, we consider it in 3 cases. First, the tightened bolt joint only bearing preload, only bearing preload, or the tightened bolt bearing axial load. And the third, the tightened bolt bearing shearing force. Okay, that's
Lodge, please, can you go over that one again, please? The last part.
which is there's this or this?
Yeah, just the last part, this side, the last part.
Oh, the third.
The
The
strength
type
calculation of Titan. No. Starts from 1, 2, 3.
1.
Mm.
The tightened bolt only bearing preload.
I don't understand.
Only bearing preload, so means it not carry the external force.
Okay.
Okay, only bearing preload. Okay.
Okay.
So for the first case, tighten the bolt joint only bearing preload. Bearing preload. We under. So let's do the strength analysis of the bolt joint in the first case. Under this condition, the bolt is subject to actual tensile load F0. F0 is the preload. FA. FA is the preload, and the friction torque T1. Friction torque T1. For tensile stress, the stress criteria is the actual tensile stress should less than the allowable stress. The actual stress acting on the bolt is FA, the actual tensile load, FA, or the preload, divided by the error. Okay, and for torsion shear stresses, the shear stress tau is equal to the torque divided by section modulus in torsion WT. And for Corman steel screw thread, the calculation can be simplified as this. The shear stress tau is equal to half of the tensile stress sigma. So for stress theory, the equivalent stress for bolt, which is subject to tensile stress only, the sigma Ka is equal to this. It's about 1.3 times sigma. So the strength criteria should be modified as this. So there is not only consider the preload, you should only consider the friction. Consider the friction. Okay, consider the friction, and we use this to calculate the sigma Ca. In this equation, the force is 1.3 times Fa. Fa is the preload. Okay? Any problem? Any problem? Because
Laoshi,
after
the torsion shear stress.
yeah,
The third one, the third equation.
this
No. You see, torsion is equal to T1 over TWT
oh
equals T1
WT
over pi. Yeah, I'm asking. Yeah, and then the next one, FATG. This one plus rho.
this
Yeah.
this is in the course material okay, in the a large course where you will learn this.
Okay.
Okay, in a large course, and you should remember this simplified formula.
Okay.
Simplified Okay.
But actually only for steel screw threads.
Only for the common steel screw thread.
Okay, Lord. Thank you.
And we use this formula to calculate the sigma CA. This is for the bolt carries preload only.
Mm.
Okay. Okay.
Lord. Mm.
And if the bolt bearing transverse working load, the friction on joint face generated by preload F0 should more than transverse load if subject to transverse load. So we have this for the preload should large than this. The C is reliability coefficient and M is the number of joint face. And F is the friction coefficient. Okay, so then we can calculate the F0, the preload should large than 8 times times the transverse load. Okay, should like so the preload is very high. The preload is very high when we design the bolt. We have this D1. The Miller diameter should large than the square root 4 times FA. FA is the preload. If the preload is very high, so the Miller diameter should be increased. Okay, so the dimension of the bolt is very large. Under this condition, the dimension is very large. So we should have some improved measurements. For A, use K-sleeve pin to bear transverse load, or use rimmed hollow bolt having no clearings. Okay, and for the second case, the tightened bolt bearing axial load. For example, the bolt on pressure vessels, we suppose that the pressure of liquid is P, bolt number is Z, then the average load of each bolt around the cylinder body is F is P times the area S and divided by the number of bolts. Okay. we should note that for axial load, FQ is not equal to preload plus the axial force. F2 is the force acting on the bolt. Under this condition, the force acting on the bolt is not equal to the preload plus the axial axial load. Now, this is the looseness state. This is the looseness state of ball. Sorry. Sorry. So this is the looseness state for the bolt, and this is the pre-tightened state. Okay, this is before preload, and this is after preload. After preload, we have this. After preload, the elongation of bolt, the bolt is lambda B0. So after preload, the bolt will it's subject to tension stress. So the bolt will elongate. The elongation of the bolt is lambda B0. Okay, and the clamped members is subjected to compression. So the shorten of the jointed members is lambda M0. So after preload, the bolt will elongate, and the members will be compressed. So the elongation for the bolt is lambda B0, and the shortening of the members is lambda MO. This is after preload. And then after loading axial force F, the F is acting on the joint. So after the F, the bolt will elongate delta lambda, and the total elongation of bolt increases to delta lambda plus lambda BO. So this is the total elongation of the bolt. Okay, total elongation of the bolt. And the shortening of the members will decrease to lambda MO minus delta lambda. Okay, delta lambda. So the remnant preload decrease to F1, and the total tensile force acting on the bolt is the preload plus F1. F1 is the remnant preload force. Okay.
Okay, lad.
And we can obviously F1 is F is the force, is the actual force. Obvious F1 is less than the preload. We can say in this, this is the bolt deformation. So when the bolt is subject to preload, the deformation is elastic or plastic.
Actually, elastic.
Elastic,
Yeah.
right? Elastic. Okay. So it satisfies the hook loss. Loss. Okay. So
Yeah.
this is the force. This is the force of preload, and this is the deformation lambda b0. Okay, so this is the elongation of the bolt when it is subject to the preload F0. Okay, so
Yeah.
they have the relationship like this, satisfy the Hooke's law. And for the members, we also have this. This is the preload, and this is the compression deformation lambda m0. Okay, lambda 0. So it also satisfies the Hooke's law. And then for this is the force, the preload. Okay, the preload. And this is the deformation of the bolt. And this is the deformation of the members. Okay.
Okay.
Okay, this is the deformation of the bolt. The bolt will elongate and the members will be compressed. Okay, this is the deformation, elastic deformation of the bolt. This is the elastic deformation of the members. So
Okay.
if actual force F is actual force F act on the joint, the bolt will elongation. Okay, and the deformation is delta lambda. Okay, delta lambda is caused by the actual force F, delta lambda. So the total deformation of bolt is lambda b0 plus delta lambda. Okay, this is the delta lambda. Okay.
Actually,
Oh, yeah.
Actually, I think it's time for break. So maybe we could take break so we can also go through this because it's a little complicated.
Sorry.
It's time for break, but and also this one is a little complicated. So if we take the break, maybe we could go through it before the next class.
Sorry, I can't hear you clearly.
Actually, I mean it's time for break for the next break, and this is also complicated. So maybe if we take the break now, it's better so that we can go look at it and analyze it before the next class.
Okay, so have a break. Okay.
Yeah. Okay.
Okay, have a break.
老师, are you here, 老师? Hello.
It's a break time, my friend.
Yeah, I know it's a break time.
Mm.
Okay, just checked this page.
Okay,
How you will
fine.
go back?
Come again?
老师, are you here?
Yeah, yeah.
老师, yeah, 老师, can you please share the PPT? We need to check the previous page. But
Okay, okay. I share it now. Okay. Where is the okay, what is
thank you, 老师.
You're welcome. Okay, let's continue.
Okay, 老师。
Okay, so the red line represents the total deformation of bolt. It's lambda b0 plus delta lambda. Lambda b0 is related to preload, and the delta lambda is caused by axial force F, and this is the total deformation. So the total force acting on the bolt is on this point. Okay, so this point represents the total force acting on bolt. It's the preload F0 plus the delta FB. Okay, delta FB. And for the members, the deformation caused by preload is lambda M0. And after the axial force loading, the blue line represents the total deformation of the member. It's lambda M0 minus delta lambda. Cause the axial force may cause the members elongate. So the total deformation is decreased. And this is the total deformation, and this point represents the actual force acting on the members. So F1 is the force acting on the members. It's equal to F0, the preload, minus delta Fm. Okay. Where the force acting on the bolt is equal to preload plus delta Fb, and it's equal to F F0 plus CB times delta lambda. Delta lambda is the deformation, and CB is the stiffness coefficient of bolt. And for members, the actual force F1 is equal to F0 minus delta Fm is equal to the preload F0 minus Cm times delta lambda. Cm is the stiffness coefficient of the members. And the actual force F is equal to delta Fm plus delta Fb. Delta Fm is the force acting on the members. Delta Fb is the force acting on the bolt. Okay, and it's equal to Cb plus Cm times delta lambda. So we can calculate the deformation delta lambda is equal to the actual force divided by Cb plus Cm. Cb and Cm are the stiff coefficient of bolt and members respectively. Then we have this. The total force acting on the bolt is F0, the preload plus CB times delta lambda. Delta lambda is this, so it's preload plus the actual force times CB divided by CB plus Cm. And then the force acting on member is F0 minus F times this. So we define this CB divided by CB plus Cm is the relative stiffness coefficient. So we have this. The strength criteria rule should be modified as this. The sigma Ca is equal to actual force divided by the area of the bolt and should be less than the allowable stress. So this is the area of the bolt, and this is 1.3 times F2. F2 is the actual force acting on the bolt. 1.3, we can, so remember this, the condition, the first condition is subject to the preload only. Consider the preload and the friction. We have this. The strength, calculated strength is equal to 1.3 times Fa. Fa is the force acting on the bolt. For the first condition, Fa is preload, and in this condition, the force the force is F2. F2 is the total force acting on the bolt. So this is the strength criteria of bolt. Under this condition, the bolt, the joint is subject to axial force. So use these two formula, we can calculate the force acting on bolt and members. And this table lists the bolt's relative stiffness coefficient, CB divided by CB plus CM. And this is for metal washer or without washer sheet. It's 0.2 to 0.3, and for rubber is 0.7, for leather is 0.8, copper is 0.9. Okay, and then we consider the third situation, the tightened bolt bearing shear force. F is the working shearing force of bolt, and D0 is the diameter of bolt shearing face. It can be diameter of bolt hole, okay? And L minimum is the minimum of height between bolt and hole wall. So the crush strength criteria of bolt and hole wall is the crush stress is equal to F divided by D0 times L minimum, and should less than allowable crush stress. And the shearing stress criteria of bolt is that the shear stress is equal to S divided by the error should less than allowable shear stress. So this is for the third conditions. If the tightened bolt bearing combined preload and variable axial load. Okay, this is variable axial load. We have consider static stress. Consider static stress. The we have this strength criteria. The calculation stress is equal to 1.3 times F2. F2 is the actual force acting on the bolt and divided by the error, and should less than the allowable stress. So the minor diameter D1 should larger than this, and this is consider the static stress. And for the variable stress, the strength criteria is different. Okay, we have learned it last week. The working stress, if the working stress cycled from 0 to F, the working stress is the actual stress working from 0 to F. The total tensile load carried by each bolt cycled from QP to Q. QP to Q is to F0. F0 is the preload and to F2. F2 is the actual stress acting on the bolt when the external axial force is F. Okay, and then we have the maximum stress. The maximum stress, we can calculate the maximum stress. Okay, it's F2. Maximum stress acting on the bolt is F2. Okay, F2 divided by the error. And the minimum stress is F0. F0 divided by the error. Okay? And then we have the stress amplitude sigma A. Sigma is half of the sigma maximum stress minus the minimum stress. So we use this minus this, so we can obtain this. So the stress amplitude is stress amplitude is this times this, and this is the stress criteria for the variable stress. Any problem? And this stress criteria is for the condition, which condition? For which condition we last week we have learned the stress criteria of alternating stress. We consider it. We consider it under three conditions. For the stress ratio is constant, or the mean stress is constant, or the minimal stress is constant. So in this condition, it's which is constant? The stress ratio, or the mean stress, or the minimal stress, which is constant? For this situation,
Laoshi, I think the mean stress.
yes, the mean stress is constant.
Ratio.
The minimal stress is constant. The minimal stress is when the working stress is 0. Okay, it's 0. So the minimal stress is F0. F0 is preload. It's preload. So the preload is constant. Okay, preload is constant. Then we use this stress criteria. The minimum stress is constant. Use this to calculate the safety factor. Okay, use this to calculate the safety factor.
Okay.
Okay, and then let's say the example. This example, this is a hydrogen cylinder with an inner diameter. Inner diameter D is 160 millimeter HU in the finger. The oil pressure P is 1, and the cylindrical barrel and the flange are connected by 8 uniformly distributed bolts, and the relative stiffness of the bolt connection is KB divided by KB plus KM is the same way in our PPT. Our PPT is CB divided by CB plus AM is the same. So the relative stiffness is 0.3, and the applied preload. So we look the preload is 2.5 times F. F is the operation force. The force is caused by the oil pressure, okay? And the allowable stress is 120. So decide one, the total tensile load carried by each bolt. Two, the resultant load on the clamped members. Three, the minor diameter required for the bolt. So first, we should calculate the total tensile stress carried by each bolt. And this condition, we three conditions. One, the bolt carries a preload only. B, the tightened bolt carries actual force. 3, the tightened bolt carries transverse force. Which condition for this example? So it's in which condition? Carries preload only, or tightened bolt carries actual force, or tightened bolt carries transverse force. In which condition?
Actually, the first condition, the total tensile load carried by each bolt.
Which?
The total tensile load carried by each bolt.
Oh, no. I said we in there. No. This for the three conditions in our example is which condition? Is which condition?
The second condition.
The second condition, the tightened bolt bearing actual load. Okay. Okay. So for the second condition, we consider the actual load. Okay, this is the equation to calculate the force acting on bolt and members. Okay, so it's the tightened bolt bearing actual load. So first, calculate the total tensile load carried by each bolt, and the external load or the actual load is shared by each bolt. Okay, it's shared by each bolt. So first we should calculate the actual force on each bolt, the F. F is equal to the pressure times the error. Okay, the pressure is P. and this is the error. Okay. This is the error of the Euler. Use the Euler diameter. Okay. This is the Euler diameter of cylinder. Okay. Euler diameter, and divided by Z. Z is the number of the bolts. So the the force caused by the oil pressure is P times the error, and the actual force is this total force divided by the number of the bolts. So we can calculate this is the Euler diameter of the cylinder, and P is 1, and Z, the number of bolts is 8. So the actual force acting on the bolt is this 2,530. Okay, and then calculate the total tensile load carried by each bolt. Okay, so the total load acting on each bolt is not preload plus the actual force. Okay, it's not equal to. We have this. We should use this calculation. Okay, and QP is the preload, and this is the relative stiffness. Okay, and F is the actual force. Okay, actual force. We know that the preload is 2.5 times actual force, and the relative stiffness is 0.3. From the example, this relative stiffness is 0.3. Okay, and then we can calculate the total tensile load carried by each force is this. And then we calculate the resultant load on the clamped members. We use this. The resultant load is the preload minus this times F. So this is not the relative stiffness. It's minus the relative stiffness. Okay, so it's the load minus 0.7 times F. So this is the resultant load on the clamped members, and the minor diameter required for the bolt. So for this, we should use the strength criteria. Right? We use this. This we have this the calculate stress is this should less than the allowable stress. So D1 should larger than this over. Okay, use this to calculate the D1. We have D1. The sigma is this, therefore the D1 should larger than the square root this. So after calculation, the minor diameter of the bolt should larger than 9.85 millimeter. Okay, any problem? Any problem for this calculation? Do you have any problem?
Actually, it's a little chunk, so it's a lot to process. But I think for me it's okay. Just a lot, plenty.
Sorry, I can't hear you clearly. Which?
Actually, I'm saying like it's a little plenty, like, but I'm on it, still on it.
Yeah, Loshi, here Q equal QP plus KB divided by KB plus KM. This equation, can you please show this equation in our PPT?
Oh, QP. Oh, this is different from our PPT, okay? It's a little different from our PPT, okay? In our
Okay.
PPT is F2. In our PPT is F2 equals to F0 plus this, okay? So it's the same. F2
Oh, okay.
F2 is Q. So F2, you should remember F2 or QP or Q or QP. And this is the total force acting on the bolt. And this is the preload. And this is the actual force. Okay? Okay. And in the example, you also can use this F2 is equal to F0 plus this. Q is F2, okay? And QP is F0. Is the same. QP is the preload. F0 is also the preload. Okay?
Okay.
Okay, so this is the total. This is F2, and this is the F0. Okay, you can use this equation on PPT, or this is the equation on your book. Use this. So use this to calculate the stress, the force on bolt and on members. And then use this to calculate the minor diameter of the bolt. So any question? Okay, let's say the exercise. A flange is attached to a pressurized cylinder by 6 identical bolts. The fluid pressure P is 2 and the inner diameter is 115. The result load on the clamped members must be kept as. So this is F double prime. It's F1. It's F1 in our PPT. Okay, F1 in our PPT. The resultant load on the members is this. So calculate the external load is shared by each bolt. So the external load is caused by the fluid pressure, okay? By the fluid pressure. And we should calculate the external load and then calculate the actual load shared by each bolt.
Okay, like it. Hold on.
So you calculate it by yourself.
Okay.
Okay. 10 minutes or 5 minutes. You need 5 minutes or 10 minutes to calculate.
We don't know how big it is, but let's
Uh,
say 10,
what?
10 minutes.
10 minutes?
Yeah, we don't know how plenty it is, but we are trying.
Okay, 10 minutes. 10 minutes.